Welcome to our live stream today. We have some awesome, exciting things to show you. Let me introduce Steve. Steve, thank you so much for being here. Steve is really passionate about Kubernetes and GitOps. I've heard him speak at various events, and it's always so interesting, informational, and engaging. But I'm not going to do him any justice, so I'll let Steve introduce himself. So Steve, please give yourself an intro.
Sure. Hey, Eddie. Thanks for inviting me. So my name's Steve Wade, currently platform lead at Metal. So we're kind of responsible for being able to deliver digital business banking to our customers. So the team that I lead is responsible for maintaining the platform. So it's a kind of Kubernetes-based platform, and we actually deploy a lot of our applications and workloads using GitOps. So hopefully we're going to be able to demonstrate some of that today. You're going to get a good understanding of taking a normal standardized Node.js app and kind of move it into a Kubernetes cluster using GitOps as a kind of pattern for that.
Awesome. I'm really excited, and it's going to be, let me explain to everyone about how it's kind of going to work. So I haven't gone through this. I haven't done this. The only thing I have done is installed some of the requirements that I needed, and we're going to show you those. I just installed them on my Mac with Brew, so I just ran a few commands, dead simple. But otherwise, I don't know what's coming up. I don't know what's happening. I'm going to pair with Steve. Steve knows everything, and he's going to walk us through it. So if you have any questions, I'm going to ask loads of questions. But if you have any questions, then just write the question in the chat. But prepend it with a Q so it stands out, and if I don't miss it. We will have some natural breaks, or we will catch up with the chat as well. So apologies if we don't get to it straight away. If we do have a break and catch up with some of the questions and we miss it, then just copy and paste your question back in, and we'll let us know that we missed it, and we'll catch up. But it's awesome to have the usual suspects, and it's awesome, I see from the chat, to have some new faces as well. Do write in the chat hey or hello and let us know that you're here. And I'm just excited to get started. And Steve, are you ready? Should I share my screen?
Let's do this.
Let's do it. Right. Okay. So if I share my screen, here we go. Is that big enough for everyone? I'll make it a bit bigger. There we go. Right. So this repo, if I just briefly explain where this repo is, it's on a few of you have seen this already and starred it and commented in the Discord. And it's on our organization, our community organization. If anyone wants to join that, just raise an issue in the support repo. I'll share some links in the chat shortly, and we can add you to our organization. So we have this live stream GitOps demo, and we will be using some issues as Steve needs to share some things with me. But I haven't looked through this. Apart from looking at the README and installing these things here, I don't know anything else that is going on. So Steve, where should we start and how should we begin?
So let's start with giving a basic understanding of the application to start with. So the app is just a simple Node.js app. So if you scroll up to source, we go in there. You'll see it's just a very simple Node.js app. All it does is essentially provides us a table listing out all of the environment variables that we give it. So it's just an example Node.js app. And uses Lightship for us to be able to provide it with a health check endpoint. So with Kubernetes, the more information we can give it about the status of our application and tell Kubernetes when the application is healthy and when it's not, the more advanced the scheduling is going to be by the time that we start to deploy this workload. So I think the natural first step is for us to create a Dockerfile and actually get this into some kind of shippable artifact that we can deploy to Kubernetes.
Sounds good. I do have a question already. What is Lightship?
So Lightship is just a framework that has allowed us to be able to provide a set of Kubernetes components. So one of those is a health check endpoint. There's other types of endpoints that you can have available to you in Kubernetes, such as a Liveness probe. It's just a way of being able to easily construct that in such a way that you don't need to have detailed understanding of Kubernetes. So a prime example here is with Lightship. We are going to say that the Lightship port is going to be on 9000, and that is going to provide us with an endpoint of localhost :9000/health, and that's going to be our health endpoint, and we don't have to do anything specifically there.
Got you. Okay, so you include it up here, and only place you use it here is at the bottom, and it does its magic, basically, is what you're saying.
Correct. Yep. It's saying detect the fact that we're running in Kubernetes, and also use that port to provide us with a health check endpoint.
Awesome. Okay. Right. What next?
So You've obviously got the repository clone. So the first thing we really need to
do.
do is create a Dockerfile. So with Dockerfiles have to start with a capital D in their file name, not a lowercase d, otherwise it won't work. So the first thing I would do is create an empty kind of file with the name Dockerfile with a capital D. And then we need to start filling this in. So when we start with a Dockerfile, we have to start from a base image. So to kind of get everybody up to speed with what we're doing here. With Docker, you create images, and they are kind of a build artifact. And then when we run them, they are what are known as containers. So what we're doing is we're going to be declaring a set of instructions here that will allow us to be able to build a Docker image. We'll get Eddie to upload that to a registry, and then we'll use that inside Kubernetes.
I thought I put it in VS Code rather than Vim. It'd be a bit more familiar to people.
Yeah. Okay, so the first thing we need to do is we need to start from a base image. So we need to choose an image that's available upstream for us to be able to build upon. So as this is a Node.js app, I'd recommend start with a from, so all in capitals.
Oh, capitals, my bad.
And then, here you're going to want Node, and then I would do
Is it like so?
Just in without the quotes.
Okay.
So Node, and then we can do colon. So that's going to be our image, and then we need to choose a tag. So I would do 16 no spaces here. So 14.6.0.
So not 16, or is 16?
No, 14.6.0.
Okay.
And then I would do a dash there and have Alpine. A dash, not a slash.
Oh, sorry, yeah. It's good.
And then Alpine there.
Okay.
That's spelt wrong. It needs to switch the P and the L around.
Oh, yeah. This is why pair programming is important.
It is. We've showed it, and we've only been live for a couple of minutes. This is great. So what we're going to do is we're going to use Alpine because Alpine is really light. So what we don't want to be doing is having a large bloated container, an image essentially that we have to lug around. We want this to be as streamlined as possible. And when I talk to developers, I always talk to them about how an image is just enough. So we don't want anything over the bare minimum here. So one of the questions that we've got in the chat are, what are the benefits of Alpine over Slim Buster? So really, Alpine as an image itself is extremely small compared to Slim Buster. So Alpine just out of the box is 2 megabytes, and then you have to actually add the stuff that you need. So what this Alpine node images is going to be the Alpine base image plus all of the dependencies that are required to run Node.
Sounds good. Harsh says, why don't we use TeamViewer, or we could use VS Code Live Share, but that's not how pairing works, right? Single keyboard.
Single keyboard, one leader, one follower. Okay, so we've got a from image, so we've got a base there to start with. The next thing we're going to want to do is set a working directory. So if you do workdir, everything in capitals, yeah, perfect. And then do here /app. So now what we're going to do is we're going to set inside our image, the working directory is /app. So then any further instructions that we do in this Docker file are going to be done in that directory. So this is just going to get us some kind of standardization. So then what we want to do is we want to copy everything. So do copy dot space dot, capitals again.
Oh yes, I must remember that. Copy dot space
dot. So that's going to... Yep, so that's going to copy everything in the present working directory inside the container. This is obviously not what we want to do, and we're going to fix this up in a second, but we're going to get a basic image running. So the next thing we're going to want to do is, after we've copied in the code or the repository, we need to run the npm. So let's run npm install. That's going to build the application. And again, yep, like Eddie's doing, you do it with the run instruction. So one of the things that we probably want to do here is let's start adding some comments for people to get a clear understanding of what's going on here. So that copy command is going to copy the present working directory inside the container. I would do it above Eddie on line 3.
Okay. Is it 2 forward slashes?
No, it's a quote. Hash, sorry.
Okay, it is.
So this is going to copy files from the local file system inside the container. Important thing to note that you're copying them to /app.
To the container.
@ /app.
Dear. Yeah.
Perfect. And then the run command is simply going to build our app for us.
Oh, wrong one. Too used to. Install dependencies. Is that correct?
Yep, we're going to exactly. Yeah. So we've got another quick question from Harsh. So how do you know which directory to put the files in, and why do you have to copy, and how do you know what do you copy? Okay, so what needs to go inside the image is everything that is required for us to be able to build the thing that we are going to execute. So for us, we need to pull in the dependencies for our Node.js app. Then we need to run essentially the build command or the build task, which in our instance is going to be run npm install. And then once we have that output, we don't really need to do anything else. Now what we're going to do is we're going to give this image a little bit more information about the ports that it's going to run on. And then finally, we're going to give it a command to run. So when a container becomes an image, what's actually happening is you're running the command that you specify at the bottom of your Dockerfile. And that's what turns it from a kind of read-only image to a writable or kind of readable container.
Following on from that question, I actually have a question. How come
Sure.
in copy we don't just copy the Node app, so the source directory?
We need to have the package.json and we need to have the package.json lock as well. So what we're going to do is we're deliberately doing this wrong, and then we're going to show a way of how we can stop this, rather than having to specify every single file one by one. So Mike asked another question here. He says, I saw /user/source/app was common at my work for work directory. Is there a best practice for folder choices? No, I think as long as you align to it at the company that you work within, I don't really think that there is a specific pattern that we follow or to follow, to be honest with you. We at Metal have all of our applications running in /app, and we just have that because it allows us to be consistent across all of our Docker containers. So when you have a number of Docker containers, the thing that's really important is you guarantee the consistency. The consistency is going to be key. It's going to make life a lot easier. Brian says Alpine is a good choice. Thanks. Okay, so we built
a Linux geek, so yeah, he's definitely going to have lots of.
Brian Linuxing. There you go. So okay, we've got that. So the next thing we need to do is we need to expose some ports. So if we use the expose instruction, the expose verb, sorry. And we know from our application that we need to expose 3000, and that was in the Node app. And then we also need to expose 9000, and that's going to be our health check endpoint. So what this is going to do is when we turn this into a running container, we are going to be able to send network traffic to it on these 2 ports.
Awesome.
Okay. And then finally, we need to actually add a command, and that's the command that's going to be run. So if we do a cmd and then square brackets, and then have in quotes node, and then comma, yeah, you know what you're doing.
I'm guessing.
And then source / index.js. So that's the command that is going to be run when we turn this image into a running container. So this is the basics of a Dockerfile. So what I think we should probably do is let's build this locally and then actually just run it and see what happens.
Okay, and then I have a question coming up in a bit. Let's get it running first, and then I'll have some questions.
Okay, so I've created a make file for us so that we can abstract some of this away so that we don't have to get Eddie to keep typing Docker commands all the time. And under the Docker specific tasks, we should add a task there for build. Yeah. So what we want to do here is we want to say Docker build -t. So let's give it a tag. Let's give it a tag for now of GitOps.
Put Git hugs.
Nice. And then space, and then finally dot. So dot, for anybody that doesn't know, is essentially saying this is the location where my Docker file exists. So it's local to the root file, to the present working directory. So we don't need to specify it. Okay, a couple of questions before we go any further.
Yeah, we've got some really good questions coming up. Nice.
So let's start with Ravi's. So Ravi is saying, what's the difference between run and CMD? So run is imagine you're writing a bash script, right? And you've got a set of commands that you want to execute in order. So run is essentially the equivalent of you constructing or modifying the file system. So let's say we want to add a directory, or we want to add a file, or we want to change the ownership of that file. All of those will be done in run. The command is the command that is executed when we boot the container. So everything above line 13 here is essentially dependencies or configuration that we require for our application to work. And then the line 13 is the thing that really is the differentiator between read-only and actually running in a container.
So am I right in saying that you can have multiple runs, but you can only have a single command?
That is correct.
Okay, so you couldn't do this, for example, but we could do that if we needed to.
Yeah, and there's a couple of things to note about runs, actually. I'm glad you actually did that. So can you just do that again and have a couple of runs? Yeah, so every time you execute a run, you create what's called a layer in Docker. And Docker basically works on a layered file system, or AUFS. So there's this trade-off between a small number of layers and kind of readability, if you want to call it that. So the more runs that Eddie has in here, the more layers, the larger the image, naturally. So what most people do is they wrap their run with a double ampersand, and they just have a load of commands that they would run exactly like this.
Something else. Okay, got you.
Yes, like that. And that will have one layer rather than 3 distinct layers.
And is there so you said as you had more layers, the file gets bigger. Is there a kind of recommended when you go, is it always recommended to do it in line, or is it recommended when you pass X amount, like if you pass more than 3 runs, then merge it into one? What is there?
So I don't really think there's necessarily a hard and fast rule. I think if you are, so let's take the example whereby you're creating a directory, you're adding a file, and you're changing the ownership of that file. That's probably one run command. And then if you're adding another directory, or maybe you're adding a user, that would be a separate run command. So there's this trade-off between one huge run command and the inability for somebody to be able to read it, or there's a lot of run commands that are readable because they're small, but you're going to increase the layers. So, but because we're using Alpine here, we're starting off from a small footprint anyway, so we can get away with multiple runs if we needed to.
To make it more readable, could you do some? Oh, you can't do something like this on multiple lines.
Yeah, you can do ampersand, and then slash.
Oh, so yeah, the slash, yes, because Linux, right? Yeah, so you could, exactly. So we could do something like that. Yep, okay, that makes it more readable.
Yeah, you can do that. That's what people normally do.
Got you. Okay, makes sense. That looks good. That's more readable for sure as well. Nice.
Okay, so Ravi, hopefully that answers your question. And then we've got a couple from Harsh. So Harsh is saying, what is a makefile? So a makefile is just a way for us to be able to abstract commands that we would normally run in a kind of higher level command that reduces complexity. So what I don't want to have to do is to get Eddie to constantly keep typing docker build -t gitops dot, right? Because you're going to fat finger it, right? To start with, we're going to mistype it. And also, if we think about a kind of CI machine or something like that, we could get the CI machine to run these make tasks rather than having some kind of really long commands that get run. We can hide that away behind a make command. So I think you've got to think about, if you're testing your application, you could just have a make task that was test, and you would always run make test. But then behind the scenes, you're doing a lot of other different testing that's very specific to the application that you're running. But inside of our CI machine or locally, I know that I'm always going to run make test.
It's a bit like, to give another example, it's a bit like people who are familiar with npm. It's a bit like the scripts commands that you have in your package JSON. So when you're working with a team, you don't want everyone to write, I don't know, node source JS. They might do it in a different directory. They might put different flags on. When developing locally, you might have start dev, you might have start for production, or start prod, however you want to name it. But everyone knows that when I'm developing locally, we're all running that same command. And when it's on production and being deployed, it's running the same command. So it's similar to this scripts make. And then, as Steve was saying, you can have, build, and we might have test. And then you can also then group things together, like all is my understanding. You kind of go all, build, and test.
That's exactly what we're going to do.
Oh, okay. I'm running a bit ahead, but getting a bit too excited.
Calm down. Okay, so a couple more questions, and then we'll continue with where we are. So, what is a layer? So, Docker works on a layered file system. So, when we pull down a node at 14.6-Alpine, we essentially start with a layer. And that layer, imagine that as just a normal Linux file system. And then every run command, what we're doing is we're creating a diff. So the way I like to talk to people about it is, imagine you're doing commits, and your run is another commit. And then when you execute your container, you essentially squash all the commits, and you create a single image that's consisted of multiple layers or multiple commits. And that's the thing that we're shipping. Does that kind of make sense?
Yeah, I think that makes sense to me. If it doesn't make sense to people watching, let us know in the chat, and we'll come back to that. Another question here: does the inline method doesn't create multiple layers? I don't think it does, from my understanding.
No, that's correct. So if you're doing it inline, it's a single layer. It's just imagine it's the equivalent of running a large bash script in one line.
Got you.
Okay, so let's build this and get it running locally, and then we'll come
back to the question.
Back to the
sure,
chat.
Sounds good.
So so if you do a make build,
so there you can see, everyone, that it's run the command that we had in the make file, which is docker build -t gitops dot. And I'll let Steve explain the rest.
So if you can scroll up for me to the so if you look here where it's doing this pull complete, those pulls are the different layers that come as part of our base image. And then what you're seeing there is we're doing the steps, and those steps are in order. And then finally at the bottom, we're doing all of so we're running the npm. If you scroll down, Eddie, we're exposing the ports, and then finally we've got the command at the end, and then out plops our container. Harsh, don't worry about many questions.
More questions, the better.
Keep them coming,
exactly. Yeah. We will get to them.
So now we've got a container. We've got an image. Sorry, let's be careful with our wording here. So we have an image, and our image by default, when you do a Docker build, is latest. So we're tagging it with latest. Wouldn't recommend doing this in production, but we're just running locally, so this is not a problem. So now if we go back to your make file, let's run a new command, and let's have a run command. So let's do if you go back to your make file, sorry, Eddie.
Oh, yeah.
So if we have a run underneath, let's create a new task here. So let's do docker run -d. So -d is kind of daemonless mode. -p, and we are going to say 3000 here, and then :3000. and then let's do GitOps : semicolon latest. Okay, so let me break this command down a second. So we're saying we want to perform a Docker run, and we want to run it in daemonless mode. So daemon mode, sorry. So what this is saying is I don't want to print the output to standard out. I just simply want you to run it in the background as if I was running on a normal server. -p here is saying I want you to expose the port. The first port that's listed there is the port on Eddie's local machine, and the second port is the port inside the container. So we know from our Dockerfile that we've exposed 3000, so we know that we can talk directly to that port. And then finally, the block at the back is simply just the image that we want to use. Okay, awesome. Let's give it a run.
Let's do it. And we just make, and we called it run was the command.
Yeah, make run.
That was quick. Okay.
It's Alpine. It's small. So now if you run the command, docker ps -a, and we can see now that we have our...
Oops, sorry. I didn't put -a. Let me... -a, we'll do that to show more, I guess. It's spread over multiple lines. Let me make it a bit smaller. I don't know if that's...
Docker ps is good. Do Docker ps, actually. Okay. It's going to be easier for them to read. Perfect. Okay, so we now have a container. And you can see that by default, Docker gives the container an arbitrary ID. The image that we're going to use is the one that Eddie just built. And then we are exposing the port 3000 on his machine. And it's going to go to 3000 inside the container. Key thing to note here, 9000 is also being specified, and that's because of the expose. So we didn't have to tell Docker anything about that. So now if you curl localhost :3000, you'll see my glorious NodeJS skills.
And it is populated though. These weren't in the weren't hard coded.
Yeah, so it simply just loops around the environment variables. So what you'll notice here is by default, Docker is giving us a couple of those out of the box. So Docker is giving us the host name, for example. So every container inside Docker gets its own unique host name. Okay.
Can you open this in the browser?
You can open this in the browser, and it should work.
Will it look really pretty?
I wouldn't go that far.
It looks pretty. It looks good. Nice. And just to make it a bit bigger, but just to prove to everyone, if we go to the node file, you can see that these weren't hard coded. So it is a loop here. So these are actually coming out. The container is running, and if I clear that and run docker ps again, you can still see it's running, and it's been up for 2 minutes now. So that's really interesting how straightforward and simple it is to containerize and get a Docker image up and running of our code, be it, it's Node producing HTML, so server-side rendering, or if we did something like, I've got a Discord bot that I want to, after this live stream, I will probably containerize and deploy. And I have questions about the deployment, but I'm going to save that for later, and where best to hosting and all that. But again, I'll save that for later when we come to the deployment side.
Sure. I think one of the good things to note here, and I think why containerization has kind of really took off, is you didn't have Node on your laptop. You didn't have to have Node. We've done this whole thing, and all you've needed is to have Docker installed.
That is very true, and that's why I love having Docker, because I can have Mongo for one project, another project might be using MySQL. I don't have to keep installing all these things on my computer. I can just go Docker pull and get the dependency that I want, and then just run that container. And for those who don't know, Docker Hub, which we're going to come up to in a bit, I don't know if I'm jumping too ahead, but has loads of different images: official ones, unofficial ones, Couchbase, Redis, Ruby, Maria, name it, you can find it. And we'll come back to that. I don't want to rush too far ahead. But yes, we have that coming soon.
Okay, so now we have an image that we've built, and we're able to turn that into a container locally. But what we really want to do is, let's imagine that we've got a Kubernetes cluster running somewhere, and we actually want to deploy this application. So we need somewhere to store these images, and that's what's known as an image registry. So what Eddie showed is Docker Hub. That is an image registry that is available to you. There are others available, but I know that Eddie has a Docker Hub account, which is going to make our life a little bit easier. So if we go into your account there, Eddie, and we go to repositories, I think. So let's create a repository for this application. So whilst you're doing that, I'll kind of explain a little bit more about what we're doing.
Do I just click create? Is it for the GitHub repo? It's not when I'm going to push it up via the command line.
You're going to push it up via the command line so we can show some more commands.
Do I need to hit create is what I mean, sorry.
You need to hit create, yeah.
Okay.
So what Eddie's going to do here is he's going to create what's called a repository in Docker Hub, and think about it as the same Docker like kind of repositories that you get in something like in GitHub. So if we, I would probably call it something in lowercase just for simplicity.
Okay.
But yeah, something like that will do.
I don't think it likes the hyphens.
It should do. I think it's because you've got a capital S.
Aha, pair programming strikes again. Nice. Perfect.
Okay, so we're going to create this repository. We need to make it public because it needs to be accessible to everybody for us to be able to deploy. We can connect it to GitHub as an option, but I want to show how we would do this in kind of like a more real world scenario. So let's not do that. So let's do a create there. So you can see here that we've now got a repository built. And now if we go to tags, Eddie, you should have no tags in there.
That's correct.
So if we go back to our make file, let's actually start to put this together and make this a little bit more fully fledged. So rather than you having to type GitOps every time, let's create a variable called app name, and then we can use that throughout. So let's do it maybe above build. Okay. I would normally do it at the top, but it's going to require a lot of scrolling. So let's do like app_name equals, and then I would use the name of the repository that we created, and that's going to make life easier.
The full name, yeah. So this one.
That one there, and then we're just going to use this all over the place.
Okay.
Then I would have image_registry, and that's going to be docker.io.
Okay.
IO. And then we'll assume that you will we do this? Hold on. You're already logged into Docker Hub. You are, aren't you?
I am, yes, yeah. On the command line and in the browser.
Okay, let's assume that we don't need to do that. So let's also specify a version, because we want to be building an actual semantically versioned image.
Yeah.
So let's do equals something like 1.1. And then if we do for now, let's just put 1, but we should really be doing this another way. But for now, this will give a good basic understanding. And then the final thing we need is image name. So if you do image name equals bracket. So you're going to want dollar open bracket, no rounded brackets, not parentheses. Yep. So you're going to want image registry there. And then at the end, slash, and then same again, dollar open brace, app_name, and then at the end of that, colon, and then dollar open bracket version. So the reason why we need to do this is because when we're tagging our image, we need to tag it with a tag that is understood by the container registry. I've actually made a mistake here. We need to put your image registry needs to be docker.io/eddyjal.
Yep.
Perfect. Okay. So now what we can do is we can start to replace commands that we're running down below with our variables. So where you've got GitOps on line 23, let's change that to dollar open brace and then img underscore name. And then, yep, the same here. Okay, so
while you're having a think, I was just going to say, hopefully everyone's still following along. I did ask in the chat, and then we've got a few yeses, and I've got a few people saying they're late. No problem. We will do a brief recap at the end as well and have a lot more Q&A. So we're trying to go through it now, but do ask questions, prepend it with a queue as we go along, and we will try and pick those up. I know we've got a couple of questions that we need to address shortly, but let's get this next state part going. I'm really excited. I'm thinking about my project that I'm going to do this.
Okay, so we know we can build, and we know we can run, right? That's the easy bit. We've done that already. So let's actually push this thing up to the image registry. So let's do a push here. So we want to make push. So let's create a push task. And we want to do, so we've built our container and we know our container is going to have that image name. So we want to do docker push and then image name. And then because I hate bloat lying around, we can do docker underneath. Docker and then do RMI in lowercase and then the same image name as well. So push is going to take our image and it's going to upload it to the registry, and RMI is essentially going to tell Docker to remove the image from the local file system because we don't want all of this bloat lying around on Eddie's machine.
And just to add a little bit more about the make-file. So I know we were talking about the make-file before about grouping commands together in terms of you can group build and run with wrap it with all, but we didn't mention, or I don't think we did, that you can actually have multiple commands underneath one section. So that's just really, really nice. So Steve's right, when we run push now, it's not only going to push it, it's going to actually also then remove it from local as well. So
let's do let's have another command actually, and we can show this. So let's do a build and push. So do a build dash or that works. And let's do no on the same line it would be.
Oh, that's true. Yeah.
And then push afterwards. Okay, so let's start with a make build. Let's just make sure we haven't broken anything. So what you'll see here is that build tag we've substituted all the variables in now.
Nice.
Okay, so let's do a build so that we've got eddyjal there, eddyjal livestream GitOps. Okay, perfect. So let's now do a make build push, and what we'll notice is that it will. So it's already built because we've already pre-built it in the previous step, and now it's going to push all of these layers up to the registry. So Harsh is asking, what is build push? So build push is another task in our makefile that rather than explicitly telling Eddie to run make build and then make push, you can combine multiple tasks together in a single task. So we could have make test, and for the test to be able to execute, we need to build the container. So this is just a way of grouping tasks together in some kind of order.
So yeah, so build has got one command in it that we can all reuse and have that consistency that we spoke about before. Push has two commands, again, grouping things together under a push. And then the build push is grouped two other tasks where it's going to run 3 commands. It's going to run the build command, and it's going to run the push command under one. It just makes it a lot easier for us.
So now, if that's worked, we should be able to go to your image registry, so Docker Hub, and actually see the tag.
If I refresh this page. Thanks for the questions, Harsh. Keep them coming, because I'm sure it's helping other people as well.
Perfect.
Oh, I see it. There we go.
Okay, so now what we can do is let's do, so if you go back to your terminal,
Yep.
If you do a Docker, no, let's do actually a make run, because make run should be using that image.
Okay.
This may fall over because
there was an error, port already allocated.
Yep, so we need to delete the old container that's running.
Oh, okay. So Docker PS, we've got this one running.
Yep, and then so we need to stop it. So yep, exactly, you got it. And then the container ID.
I remember someone saying you could do it with the names as well. I always do it with the ID. Is that possible to do?
You can do it with you can do it with the names. And then Docker kill.
Docker kill. It's a bit harsh.
Oh no! Ignore me. You're running a different type of container. I'm in Meta World.
Okay. Do I need to remove it? Because if I go Docker PS -a, we will see 2 there. Do I need to remove those, or are they okay to stay?
You should be okay, because we can run multiple containers from the same image. So there's a one-to-many.
Got you. Okay, that's good.
So we're not exposing any ports because it failed on the top one. So you should be able to make run again, and it should hopefully now work.
That looks better.
And then if you do your curl in the browser,
let's have a look in the browser. Oh, and the host name has changed.
Perfect. So we haven't broken anything. That's a good start.
And Shubham asks, does the order matter in the make file? I don't think it does, because you call these as you need it.
Yeah, so you can call them in any order that you want, because they are singly executed tasks or instructions. The only one that does matter is line 32 there, the build push, and they are executed in order.
Yeah, so build will execute first and then push. Because when we run this command, build push, or this task, it will run that and then that. But as these ones, Steve's right, we call these as and when we need them. So we could call build, then we could call push, and then we could call run. But in build push, again, it helps that consistency when working with a team or a public project. You don't have to worry about, do I run push first or build first? It's just run, build, push, and it will do it in the right order for the next person.
That's correct. And normally what I do is when I'm running a make file, I'm thinking about how I would want to be using it, and that's the order that I kind of write these instructions in. So push was the last thing we did because we wanted to get it running locally. So we had to build to get it to run. So build, run, and then push. It's kind of the logical steps.
Makes sense.
Okay, let's stop there for a second, see if we've got any questions about Docker before we really move on to Kube here.
Yeah, really exciting. So I'll let you have a read of the chat as well, see if we've missed anything. If we've missed anything, let us know. Got Ritesh saying full K8 managed service by AWS. Yeah, I hear that's quite good, but I've got questions about that later on. I'll save it till the end after we've gone through that to talk more about different services where we can host Docker files, where we can host Kube clusters and so forth. So that's awesome. How's everyone doing? Everyone's still awake? Everyone's still with us? If you have any questions, now's the time. And before we show you the Kubernetes part, this is the Docker part using Makefile.
Is more layers bad? So more layers aren't necessarily bad, but the more layers you have, the larger the image. And if we're thinking about productionized systems where we have maybe hundreds or thousands of these containers and hundreds of thousands of images, we have to put these layers somewhere, right? They have to live on a file system. Luckily for us right now, they're in Docker Hub. But imagine if this was on Eddie's machine, this would start to take a lot of space. And as well as that, when we are pulling them from registries, it's a lot to put over the network. So the smaller footprint we have, the less layers, the smaller the size, the faster we can deploy things. Are we going to cover release tasks with Kubernetes? Yeah, we're gonna deploy this app, and then Eddie's gonna make a change, and then it's gonna automatically deploy the new version for us. That's where I'm hoping we can get to.
Awesome. Okay, I'm conscious of time, so maybe we should move on to the next section, and we'll come back to questions shortly.
Sure. So let's now actually turn this into some manifests that we can deploy. So what I'm going to do is I'm going to create an issue, and the issue is going to contain all of the manifests that we need, and it's going to save us from having to manually create those. So let me just create an issue.
Sounds good. I actually do have a question about that. So we're going to deploy, like you said, with Kubernetes and so on. Is it possible to deploy just what we've got so far? I'm not saying we do that today, but is there a service on AWS or on Google, GCP?
Yeah, so there's loads of, so like we could use something like Docker Swarm, which is a container orchestrator. We could use something like EKS, so ECS, sorry, which is Amazon's kind of container orchestrator. There are a number of different orchestration tools that are available to us. But in this example that we're using here, we're going to be running this on Kubernetes.
And then just to recap for people, the advantages is like scaling. It does a lot more, right? To put.
Absolutely. So yeah, exactly. So we're going to get a lot of the stuff that you'd have to normally do manually, but we're going to get that out of the box with Kubernetes. So we're going to get a lot of this stuff already for us. So automatic rolling updates, scaling. So Eddie's got one container deployed locally right now. When we deploy into Kubernetes, we don't want to be running a single instance. We want to be running multiple. So we're going to do that as well. So we're going to kind of turn something that is very simplistic in its nature for local development, and we're going to turn it into something a little bit more kind of production grade for us to be able to deploy into a normal working system. So,
awesome.
Eddie, I have created an issue.
Okay, let's go have a look.
That contains our manifests. So what we're going to want to do is some of this is deliberately wrong on purpose, because I want us to go through it and kind of explain each piece. So what we want to do is, if we go back to, if we copy these blocks, and then inside the customized directory, you're going to see two other directories. Well, you're going to see one actually, because we need to create the other one. So if we create another directory called base, and then inside here, we're going to create a new file, and that file is going to be called deployment.yaml.
The first
might
one?
have to be, might have to be YAML rather than YML.
Oh yeah. Pair programming comes to the rescue again.
Okay, so let's do the same with the other ones, and then we'll come back and actually fix this up. So if you copy across the service, that's the namespace there.
Okay, what's this one called? Is it in base as well?
Yeah, everything that we're doing will be in base. So another one called namespace.yaml.
Namespace. While I'm doing this, there's a question which is actually quite good. What are the manifests? What are they and what are they for? Namespace.
Sure. So to Harsh's point, YML is the same as YAML, but I'm just kind of a stickler for consistency. So as it's a YAML file, we'll name the file name YAML. But you're right.
Yeah, the other ones were YAML, so it's good to be consistent and not mix them in the project. So I think that's good.
So what are manifests? So let's go down each manifest after Eddie's copied them in, and we can kind of explain how this works.
Was it service, this one called? The last one?
That's correct. Yep, you've got it. So a namespace is inside of Kubernetes. If you imagine what Kubernetes tries to do, is it tries to see a lot of infrastructure as a single machine. That's its kind of job. It allows us to be able to target deployments. And this is the thing that we are going to do. We're going to target the deployment, and the deployment that we are going to target is going to be the application itself, right? The Dockerfile, the Docker image. Let me get my terminology right. So what a namespace is it's a way of segregating a certain area of the cluster for different types of resources. So we are going to create a namespace here. We can call it whatever we want. Let's call it live stream, or call it Eddie, or whatever.
Is that this part here?
That's this part here, yeah. And
okay.
And the way that we want to see this is, imagine this as a kind of a vertical tube or a vertical column where we are going to deploy the other manifests. So the service and the deployment. So it's just a namespace is a way of segregating up the cluster into multiple different areas. And think about this as if you're running a company, you may have different namespaces for different products that you're using. So say you've got a front end team and a back end team. You may have a namespace for front end, you may have a namespace for back end, and then they deploy into those different namespaces.
Another way to look at namespaces, I suppose, is almost like folders, would you say, like directories? If you had, you might have, like I said, front end and back end, and even under those, you might have an additional namespace as well, which kind of like a sub namespace.
You can only, there's no such thing as sub namespaces in Kube, in Kubernetes. So yeah, I would say that if we were going down the kind of folder analogy, you would it would be a subdirectory for a namespace, and then inside there you would have your files, and then you'd have another directory for, say, backend, and you'd have all the files that related to backend in there.
Okay.
Okay, so we've got a namespace. We can leave it as example node app if we want for time,
yep,
or we can change it to something else.
I'll leave it for now.
Okay, and then we have a service. So let's go to service next. Actually, let's go to deployment first. It's going to make more sense.
Yeah, no problem. Well, everyone watching, just to remind everyone, don't forget to give the video a thumbs up. It really helps support the channel. And if you haven't subscribed already, do hit subscribe. And if you want to join the conversation between live streams and videos, there's a Discord link in the description below. And don't forget to follow Steve. His Twitter link is in the description below too.
So a deployment is a resource inside of Kubernetes that's going to allow us to be able to deploy the containers that we want. So to step back a bit, what Eddie's been deploying locally are containers or a container, but inside Kubernetes has the concept of pods. In our example, we're going to have one container inside a pod. You could have one or more containers inside a pod if you wanted to. When we deploy things to Kubernetes, we deploy pods. We don't deploy containers. That's a key kind of thing to note. And to Harsh's point, a manifest is just one of these files that's a resource that we deploy into Kubernetes. So I'm calling them manifests. You could call them resources. And resources are objects, essentially, that we are deploying to Kubernetes. So a namespace, namespace.yaml is a manifest, but it is going to deploy a namespace resource to the Kubernetes cluster. And then we're going to have a service resource, and then we're going to have a deployment resource as well. So our deployment, everything that we do has to target a namespace. So that's why you'll see namespace there. And the deployment has also got a name. And then we're going to say that for this deployment, we want to have 3 replicas. So that's line 9 there. So we're going to have 3 running containers. And then we're going to have a strategy for upgrading. So we're going to perform a rolling update strategy. And that is essentially going to say, when we go from version 1.1.1 to version 1.1.2, we are going to perform that in a rolling fashion. So again, we're declaring YAML. Kubernetes can understand this and is going to do a lot of the heavy lifting for us, which is awesome. Selectors, we'll kind of gloss over that for a minute until we go to services. The thing I really want to talk about is the spec. So here's our container that we're going to talk about. So our container here, we need to give it a name. So let's give it the name, Eddie, that we put in the make file. Line 17. Yeah, let's do that. And then the image that we want to deploy is going to be your one. So that's going to be Docker IO. So yeah, if you take the image registry line and replace that part, and then put the name, replace example node app with live stream GitOps demo. Okay, perfect. So that's going to be the image that we're going to use. And then the port is the port that our application runs on, which is 3000, as we've discussed before. And then Kubernetes has this concept of liveness and readiness probes. And what this is doing is it's going to tell Kubernetes when our application is actually ready to service live traffic. So we know that we've got that on port 9000, and we have a /health endpoint, and that was coming from Lightship. So we now have the basis of us being able to deploy a YAML file, or a deployment, of 3 replicas of our container, but we need some way of being able to access it. So our service.yaml is simply a way for us to be able to target that application. So we are saying that our container image, or our pod port, is on 3000. But we want to access that from a service that is on port 80. So imagine a service is kind of like a load balancer. So you're saying on the inbound, we're going to take it inbound on port 80. And then our nodes, if we were thinking about load balancers, are receiving traffic on 3000, but that's our pod. So when you think about services, think of kind of like a load balancer, inbound and outbound communication.
We do have a question, just to kind of, there's a lot of good information to take in, and a lot of YAML. One of the questions is the liveliness and ready, which was here, liveliness and readiness. So I know we're using what was it called?
Lightship.
Lightship. And do you have to use that? And can you omit this, or then then Kubernetes won't know when things are ready and when to get traffic towards it?
So the liveness and readiness probes is us providing Kubernetes with more information about the app. So we could admit this, but within reason, assume that you are connecting to a database. We've got a very simplistic application here, and you needed to go and get some credentials, and you wanted to attempt to establish a connection to the database before you receive live traffic. You need a way to tell Kubernetes, actually, can you just hold on a minute?
Got you.
I'm not ready.
So it removes the cold start. So sometimes to connect to a database, I know people were getting to Mongo and Atlas, and it took I don't know, 300 or 500 milliseconds for the first connection for that container. So you're right, that's really good. So they can tell Kubernetes to hold off, don't send traffic to that container. And we've got 3 of them, if I remember correctly. So I saw somewhere, we've got 3 replicas. So when you're doing a rolling update, don't send any traffic to that specific container until it's got a healthy connection. And that's really good. And just to show people what, here it is. Again, Lightship, all we did was include the library at the top with a require. And then we've given a default port of 9000. We can overwrite it if we wanted to, an environment variable. And then we've called their function, and we say that it's ready. And that's all we've done. So it's not like we're writing lots of code to use that, but it gives
in the deployment.
Deployment. Thank you. It gives an endpoint here. Health. Did we specify health, or was that specified?
No. So this is what Lightship's doing for you.
Got you. Okay. So that's awesome. So on health, on 9000, we know that liveness and readiness are just taken care of, which I think is great.
Yeah. So the cold start is a great example. So imagine a Java app, right? Notoriously a little bit slow to start, but once it's kicked into gear, it's all systems go. But imagine we've got hundreds and hundreds of Java apps that are consuming resources. We want to say, actually, can you not do anything for a minute and then try and talk to me? So we're saying here that don't do anything for 30 seconds, and that's lines 36 and 43. And then try for another 10 seconds, and then if you fail, give up. So this has essentially got 40 seconds to work. Otherwise, Kubernetes is going to think that something's not right.
And will it then destroy the container and try and rebuild it, or is that something for us?
It will constantly in the background be restarting it and trying to get it online.
Awesome.
Okay. So that's going to be our base level configuration. So now what we probably want to do is talk about what we're actually going to set up. So if you go back to the repo in GitHub, Eddie, I actually created a couple of files that will probably be quite useful to go through. So if you go back to docs, and then let's talk about what GitOps actually is. No, actually, let's do how to use. Let's go back, actually. Yeah, let's do how to use the repo. So I've put a lot of boilerplate text in here, but I'm going to kind of gloss over that a little bit and talk specifically to the image, because I think the image is kind of what makes the most sense. So normally you could apply these manifests using a binary called kubectl, and you would be pushing those into the Kubernetes cluster and they would deploy. But in the GitOps paradigm, we kind of switched that the other way. So we're going to have an agent inside the cluster, and that's the Flux CD down there in the bottom. And it is going to be responsible for syncing the state from Git. So we are going to store the state in GitHub. Eddie's going to actually commit these YAML files, and the agent inside the Kubernetes cluster is going to pick those up and be the thing that is responsible for actually performing the deployment. So we're not going to do kubectl apply. We are going to declare the state of the world inside GitHub, and then the agent inside of Kubernetes is going to be the thing that actually makes that happen.
Oh, interesting. Okay, so it's not going to be CI that does something and pushes something out to somewhere. It's going to be Flux noticing that something's changed and do the updates.
Correct. So the first one we're going to do is we're going to do the sync from the Git repo. And then the final one that we're going to do is we're actually going to get Flux to poll for new images with your tag. And we're going to create a tag of 1.1.2, and we're going to see Flux automatically pull that into the cluster without us having to do it.
Okay.
Okay, so let's go back to our repo. So we've got some YAML files here. That's great. And then what we want to do is in...
Hopefully everyone is still following along. You're all still awake in the heat. We've got a major heat wave in the UK. Wherever you are in the world, hopefully, yeah, you're still awake. Don't forget, if you have any questions, put a Q in front of it. And if we have missed any questions, just copy and paste them back in and we will get to them shortly. Sorry, Steve, go ahead.
No, you're good. So yeah, we've got a directory inside customize base. What I want us to be able to do there is inside of the base directory, if we create another folder and we just call this demo for now. And then if you drag those files inside that demo directory for me. And then we need to create another file here. So that the file that we're going to create is customization.yaml.
Under demo as well.
Yep, under demo. So customization with a K.
Ah, that's a tricky one. Customization with a Z as well?
With a Z.
American spelling. Zation.yaml. Does that look okay?
Okay. Yeah, that looks good. And then for speed, if you copy and paste the customization.yaml that you have in dev, the contents of it.
Oh yeah, got you.
Oh, it's empty. Brilliant. Okay. So let's.
Do you want to add it to the GitHub issues?
Yeah, I'll add it to the GitHub issues for now. That's going to make
cool. And then I'll share this this repo on the command line again if anyone wants to have a look, because we will be pushing more things up to this repo. So do follow along.
So I'm going to keep adding to that same issue. So to make life easier for everybody.
Oh, you don't want extra green squares? Okay. No worries.
So yeah, let's copy that in. That's not correct, but we're going to edit it. So what we want to do here is we need to specify the resources that come together to construct demo. So here we need to, instead of having namespaces /demo /namespaces.yaml, we just need to say namespace.yaml, and then another line for service.yaml, and then another line for deployment.yaml.
Sorry, we just to include the other ones, right? Okay.
Yeah, so we need to include them in here. So line 4 needs to be replaced with just namespace.yaml.
Got you.
And then we need to add some other ones in here. So yeah, for deployment.yaml, and then another one for service.yaml. What Customize is doing for the people that are kind of watching along is we are going to combine all of these resources together and essentially state that they come as a package. So when we deploy the demo directory, we are going to be deploying all of the YAML files that are combined in this customization.yaml. So then if you copy the demo directory from here and actually drop it into dev.
To copy it or move it? Copy it.
Copy it.
Okay.
Perfect. Okay. So here, if we delete everything but customization.yaml.
Delete everything
so leave
but
customization.
That one. Okay.
Yeah, and then delete this.
Oh, what happened there? Did that work? Yeah, it did. Okay, it just all bumped up. Okay, we're good. I think, right? Dev, demo, customization only, and then those are all still there.
Yeah, that looks good. So inside of resources now, we want to basically state here that we want to go back up to base and obtain the YAML files. So in resource in here, yeah. So we want to, instead of declaring these, we want to declare one, and it's going to be // base demo. Yeah, we don't need no. We don't need namespace.yaml. So lines 5 and 6 can go. And just
5 and 6. So you don't need namespace, or you don't need 5 and 6.
Don't need 5 and 6, and then on line 4 we don't need namespace.yaml.
Oh, you can just put the folder.
Yeah, so we're going to say that we're going to tell Customize to. So how Customize works is it runs the tree of the customization.yamls. So we are going to say, for here, we need you to go to base and get everything inside of the demo directory inside base. So we're not going to be doing any overrides here. We're just going to pull it in.
Got you. Okay.
So imagine that we have and where we've got dev here, imagine we have another directory called staging, and we would do the same thing. And we would be able to make changes between dev and staging. But because we've only got one cluster, this is just dev here.
Makes sense. Nice.
Okay, so then in your customization inside of dev, in the file below the one that you're on.
This one.
Yep,
yeah.
that one there. So copy and paste the customization.yaml from there, from the one above. And then where you've got resources, just put demo there. So what we're going to say is we're going to point Flux at the dev directory. The dev directory has a customization.yaml here. You don't need the /ed, by the way.
Okay.
On line 4.
I think I did it on the other file. Let me check. So I remove that one as well.
Yeah, you can remove that one as well. Yeah.
Okay.
So we're going to start at the bottom, and we're going to say, okay, the resources that we're going to start with are going to be demo. And then inside the demo directory, we have another customization.yaml. And that customization.yaml goes up to base and gets the files. So to Harsh's point, Harsh is saying, why are we doing this dev and base stuff? So the reason why we're doing this dev and base stuff is because imagine you had multiple different environments and you had a different cluster for each environment. What we could do here is we're defining a lot of the stuff in base, but we're using it inside different environments. So let's assume that inside base, we had different products. Let's just talk about Metal for now. We have a product called Evie, and we have a product called Identity. Inside of dev, we may want Evie. Inside of staging, we may want Identity. And then inside of production, we may want Evie and Identity. So what we're doing is base is kind of a pick a mix. And then inside the environment, we're choosing what suites we want or what directories we want to use. And it just allows us to be able to add and pick and choose what resources and what products we want to be able to deploy. So that's a little bit to grok here and kind of get. So essentially what we're doing is we're going to have a way of being able to crawl the tree And now what we need to do is we've got a way of being able to combine these resources together. We now need to deploy the agent inside to know where to look at. So
can we just clarify something that Mike asks?
Sure.
So the product is called demo, not the environment.
Correct. So in this example, the product that we're going to deploy is called demo. And then inside of Eddie's dev directory, we are including that product. So we're including demo. And let's say, for example, there was a Steve product, and I also had a number of different manifests. And then inside dev, I would include both demo and Steve if I wanted to. It's just a way of collecting different products together in a given environment. So the whole premise behind this, again, with GitOps, is we want to declare things in Git. So all we're doing is we're declaring what we want environments to look like. Okay, Mike gave the thumbs up, so that's good. So inside of our make file, I added another task for us.
Okay, cool.
At the bottom, there is a make test. So what this does is we are going to create a new directory called _test, and then we're going to do a customized build, and we're going to point it at customize /, and that's just going to be our dev directory. And this is what Flux is doing inside of Kubernetes. It does it builds all of the YAML files, and then it throws them at the Kubernetes cluster. So what we're going to do is we're going to do the equivalent locally to make sure that Stephen hasn't messed something up. So if you run make test -dev.
Oh, is that why you've got the percentage there? So it can take a variable.
It can take an arbitrary variable, yeah. And
then where does it put it?
It uses that in the $.
Oh, nice. That's a nice feature. Very, very nice. So you can make things more reusable. I like that. Okay, let's make some space here. So we said make, test, and we're choosing dev.
That's correct.
Let's go.
Okay, so that output. So now if we go to that file in here, exactly.
Okay.
And now what you'll see is it's all of the YAML files that we just stipulated in base. So you'll see it all in here now.
And also, but all separated, so you can check that the config is what we wanted. That it got kind of
correct, right? So we don't
exactly.
So I imagine we're doing this as a PR. If we had a nice way of being able to automate this customized build as a comment inside our PR, we could read it, make sure that we were happy with it before we merge it into master, and then away we go. So what I would do now is I would delete the _test directory because we don't want to really commit that to Git, but commit the rest of this to Git.
Okay. And if anyone wants to raise a pull request on the repo, add a git ignore file and then have _test be ignored so no accidents happen in the future. Right, so if I do a git status, see what we've got. We've got updated the make file, updated the customized YAML file, and we've got a couple of new folders and a new file. So I want all those, so just check. If I add all those, I can double check that I'm happy with all of those. There's no private password files, nothing secret going up or anything like, I don't know, dot something. I see people committing hundreds of files just auto-generated from an IDE or something. So good to just check that. I'm happy with that, so I want to commit that. What should we call this? So here we've done mostly kind of the Dockerfile. So
we've done Dockerfile and customize.
Yep. So Dockerfile, I could commit them separately. You can commit as one, but I'll just say Docker and customize, and I'll commit all that, and then I can go push that to master. Oh, I spelled my name wrong. Aha, there's updates in the thing. Okay, no worries. It wouldn't be a live stream if things didn't go wrong. So there's new updates in the repo. So I need to pull those down first. So if there's no conflicts by the looks of it, and they are going to be merged in, and then now I can push that up again. Perfect. Okay, so that's pushed up, and if I go to the repo, we will see 21 seconds ago. That was me. Awesome.
Okay, so now we've got the basis of something that we can actually start to get deployed. So if we go back to our code.
Yeah.
So what you're seeing here, if we probably close all of these tabs, if we open inside scripts, I have a Flux init script. Okay, so for those of you to know, I got Eddie to create us a Kubernetes cluster locally using a tool called K3D by Rancher. It's in the README of the repository, so go and check it out. It essentially allows us to be able to create a Kubernetes cluster locally that we can then deploy to. So what we're going to do is we need to make a couple of changes to this repo. So line 19, we are going to be telling Flux that it needs to look at that customized /dev directory, which is correct. That's where we want to deploy from. We are going to tell it the URL of the repo, which is going to be Eddie's community repository. We're going to tell it that we want it to track the master branch. And then if we keep going down, the first thing we're going to need to do is deploy Flux. So Flux is going to be the agent that runs inside of Kubernetes. And again, there you can see that when we deploy Flux, we need to tell it the Git information. So we need to tell it the URL, the branch, and the path that we want to specify. That command there is a way of shorthand. Line 30 is a way of creating a namespace manually. So this is going to provide us with a Flux instance. And when Flux creates, by default, it creates a key. And what we're going to do is we're going to get that key out of Flux, and Eddie's going to add it to his repository. And that is going to establish a connection from Flux to the repository. And then the sync is going to happen. And we are going to get the YAMLs deployed to the Kubernetes cluster if everything works out well.
I'm feeling positive. So, who's feeling positive? Right? Give us a thumbs up in the chat if you're still awake.
Yeah, thumbs
I'm
up
feeling
if
positive.
It's going to work first time. Live demos. Okay, so let's. I think I abstracted this away in a make task. So we should just be able to run. I think it's make install -flux. There we go.
Okay.
So let's give this a run.
Right, who's feeling positive? We got a thumbs up from Mike. I don't know if that's a new one or an old thumbs up, but I'll take it anyway.
Yeah, it was an old thumbs up. I'm going to take it right now.
Yeah, I'm good. Like on a 1 to 10, how positive are you feeling, Steve? I'm feeling like a 7, maybe an 8. I have faith in you.
I'm going to go with a 9. I want to live dangerously.
Okay. Right, Mohammed's still here. Mohammed's positive always. He's a 10, and he's eagle eyes. He spots everything. He hasn't spotted anything yet, so I think we're doing okay.
10 out of 10, Mike Rogers. Nice.
Nice. Thank you. Let's do it.
Awesome.
Right.
Okay, so let's install Flux.
3,
so all
2,
doing,
1.
This is the easy bit.
Oh, okay.
Okay. You have lost your connection to Kubernetes in that regard.
Unreachable.
Yeah. So your kube config is not pointing at the cluster. I can fix this for you. I'll paste something in the chat.
Please do, because I'm lost now. This is why we're all here to learn from Steve. This is awesome. I think up to the Docker stuff, getting Docker running locally, I can repeat that, makes sense. Then now this side, I'm going to have to rewatch it myself because, yeah, there's a lot of things in those YAML files. I probably could, they're templates, you could kind of reuse most of it, I reckon, just change some config, but I couldn't come up with it at the top of my head, and that probably goes for a lot of people watching as well, so I might have to rewatch and see. Alex has just joined. Alex has missed all the fun, but I will do a live stream in the future, Alex, on doing the Docker side and deploying the Docker bit, and I've got some questions for Steve later on about that. So I think work with EddieBot for our Discord channel. I don't think I need to run that on Kubernetes. I don't need like a cluster of 5 or 10 of them and do rolling updates. So I think running on Docker could be more beneficial than running where I am now.
Okay, I have pasted something in the issue, which should be the command that we need to be able to re-establish your connection.
Okay, and what
so I can explain what this is doing. So K3D is the tool that we use to stand up the Kubernetes cluster, and what we need to do is k3d kubeconfig. I'll just do get. So in your command, do k3d kubeconfig get, and then dash name.
Like that?
Yeah. Yeah.
We haven't had anything go wrong so far, so it's about time something went wrong. So this is fine, and I can catch up with the chat. Alex, yeah, missed most of it. Yeah, watch it when it gets reposted by YouTube, because if you watch it straight after the stream, it will be a lower quality, because what YouTube will do is try to render it, and that can take between like 2 hours and 24 hours. It depends how busy YouTube and Google are. So if you do want to kind of rewatch the stream and catch up on it, I mean, you can do it, see what the quality's like. If the quality isn't great, then you might have to wait for it to be kind of notified, pushed out on my page.
Okay, so k3d kubeconfig get, and then remove everything after that up to the brackets and just replace it with the word GitOps. So, yep, delete. Yep, and then take out that extra. Leave GitOps there and take out that. Yep, that should do it.
I did delete the cluster last time. Is that why I made it?
Yeah, that would do it.
I messaged you on Twitter. You might have missed it. I created the cluster, but I also destroyed it as well to start again to show everyone what it was.
So let's do that. So sorry. Make cluster.
Yeah, I did something and to check it worked before the stream. I didn't know what I was doing. I just ran that command, but then I did destroy it because I wanted to recreate it to show everybody. So make cluster. No, it's bad communication. It happens. I completely forgot I did that as well. So it's doing k3d cluster create agents to GitOps. So can you explain what that does?
Sure. So Kubernetes out of the box needs a master node, and the master node is really the thing that provides us with the API for us to be able to deploy. And agents is essentially saying that we're going to have 2 worker nodes, or 2 nodes that are going to be able to allow us to deploy containers to. So our cluster is going to be 3 nodes. It's going to be a master node, because we have to have a master node, plus 2 agents. And then the name of the cluster, we're going to call it GitOps. So that's going to be the name. So that's all that's doing.
Got you. Okay. Right, that should be up and running now, and it is.
Okay, so if you do kubectl get nodes.
kubectl.
You're missing an either.
Oh, yeah. I'm missing too many letters now. Here we go. Yep. Sorry. Get clusters.
Get nodes.
I'll get nodes. The 2 words, 1 word.
You're good like this.
Like that.
Yeah, that's perfect. Okay, perfect. So we have 1 master node, or what they call a server, and then we have 2 agents. So Harsh is asking the question of what do the agents do? So the agents are the machines that are going to run our workload. So our workloads are going to be our demo app that we're going to deploy. So they are the nodes that are going to be responsible for running those containers for us. Okay, so now if we do another make install Flux, we should be in a position whereby... Yeah.
Now I'm feeling 10 out of 10 now.
Now we're back to 10 out of 10.
Okay.
Okay, cool. So we're going to create a namespace. And now we're going to install Flux. So this takes a little bit of time.
I just realized I've got my green screen up and like you haven't got one, and I should have put like a black box around me or something. I just noticed that looking up at my screen above. For those of you who wonder why. Sorry, go on.
So Flux has been installed. So the key thing to note here is that when Eddie adds this deploy key to GitHub, Flux is going to wait for that, and Flux is now sitting there constantly trying to establish a connection to GitHub.
To GitHub or to
the GitHub repository?
Okay.
To the GitHub the repository.
Okay. Is this private, by the way? Should I be worried that it's on a live stream?
No, because the minute we delete the cluster, it's all gone.
Got you. Okay.
So when Eddie uploads this deploy key to the cluster, Flux is going to start to reconcile. So let's add the key to GitHub.
Where I'm adding it on GitHub?
So if you scroll up to settings, go to deploy keys, give it a name of GitOps, and then importantly, make sure that we tick the box at the bottom. So we need to allow write access. So
And
yeah, let's.
the deploy keys is if someone has this, then they can write to the repo. Is that my understanding?
They can read and write from the repo, yeah. In this
it.
scenario, they can read and write. So
Okay.
Flux is going to be the thing that can read and write.
Hopefully my password won't show. 1, 2, 3, it's fine.
Okay, fine. So now if we go back to the terminal, we should see, if we wait for a couple of seconds, that connection is going to be established. And then Flux is we're going to get a command that says the bootstrap has been complete.
Okay, while we're waiting, I'm going to show everyone my setup if they haven't seen it before, because I do love showing my setup. This is why I keep looking up, because Steve and me are up there on my big screen. That's why. Oh, something's happened.
Okay, so it's been done. So now if we go to, if we start to do some kubectl commands, so if you do kubectl get namespaces, get and then space namespaces.
Kubectl
space get space namespaces.
Namespaces. I want to copy and paste that for next time.
So you'll see now we've got the namespace example node app. So now if we do kubectl get pods -n, so pods are the unit of things, the unit that we're scheduling, and then space after pods -n and then space, and then you can paste example node app from the output above.
Oh yeah, I see what you mean. I got you. Okay, so these remind me again. These are the namespaces, and those aren't ours. It's basically we've created this namespace.
We've created that namespace, and then also we've created another namespace called Flux, where our Flux instance sits.
Okay.
So yeah, if we hit this, so we now have 3 pods that are running. So the 3 pods are going to be the pods for our apps. So we've done our first deployment of our demo application.
And remind me again, a pod is not a single container. It could contain
a pod
multiple.
Can be one or more.
One or more. Okay. And in this instance, each container is in its own pod.
Each container is in its own pod. That's correct.
Okay.
So Kubernetes only understands the concept of pods. We don't talk about containers specifically, but that's the thing that we are deploying.
Got you. Okay.
Okay. So to kind of recap what we've done there. So Eddie installed the Flux agent. The Flux agent gave us a deploy key. We uploaded that deploy key to GitHub. The reconciliation or the sync happened, and we have now sunk the manifests from Git into our cluster. Right. So Eddie didn't do any kubectl applies. This was all done for us thanks to Flux. So that's kind of where we're at right now. So I'm going to kind of stop there and open the floor up to some questions before we do the final piece of this puzzle.
And what is the final piece? Remind me. Doing an update.
So the final piece is we are going to add some more metadata to tell Flux to look for new images, and then we're going to upload a new image, and then we're going to see the update happen.
Will we notice the rolling update, or will it happen too fast?
No, it will happen. We'll put a watch on here, and then you'll be able to see it.
Nice. Cool. So people watching, questions right in the chat. Also, let us know if you've used Docker or Kubernetes before. I noticed we had a few people who had. And if you haven't, do you think you'll use it in the near future? And if you haven't got questions, I've got questions, but at least on the Docker side first as well for Steve. So I can, until we get questions in the chat, I can jump in. So you mentioned that we could deploy Docker in, what did you call it? On AWS, what was the name you gave it?
ECS, so Elastic Container Service.
And then how straightforward is it to ECS? How straightforward is it for someone to deploy to that? Is it a lot of it managed for us?
Yeah, it's essentially a managed service. It gives you it's the equivalent of what we're kind of doing now. So the actual running of the cluster is abstracted away from you, and it just provides you with a platform or an abstraction where you're targeting running the containers. So you just tell it keep Docker run essentially, but point it at the at ECS, and it will do the kind of heavy lifting of actually going and getting the container and spinning it up and putting it at a specific port.
Awesome. That sounds good. I'll open that for later to have a read. Okay, we do have a question. Where can we learn K8, and where do we use it?
So where can we learn Kubernetes? I can do a little bit of a sales pitch and tell you that I give training. But as well as that, there are a number of other tools. So there's a online tool called Katacoda. So Katacoda.
Let me bring that up. And spell it Katacoda. Got you. This one, good?
Yeah, so this is just a kind of online portal that has a number of different tools and technologies that you can use. So if you're new to Docker, they have a whole online lab that is specific to Docker, one specific to Kubernetes. Yeah, you can see it down here.
Got you.
Yeah, there's loads here that are available to you to use.
What is the pricing of this? Do you know?
I think you can do the free. They're all free, and then there's some kind of enterprise ones that are specifically you have to pay for.
Nice.
So yeah, this goes through everything.
Okay, wow. What is a container, etc. Running containers, launch private registry. Nice. Looks good. And then where to use it, I would say if you've got, again, in my case, like EddieBot on our Discord channel, probably Docker's enough. Probably don't need Kubernetes for that, because I don't need rolling updates. I don't need, a cluster. I don't need like 4, 5, 10 instances of them. But I do see when you do want that load balanced, and you do want, and there's probably a lot more features that I'm not talking about, but like load balancing is what we've spoken about today. And with rolling update, where you can just change some config and it automatically scales it out, I can definitely see Kubernetes making that so much easier, not having to worry about, I don't know, if you've got 2 containers and you're trying to manually load balance and you have to know which one have you updated and then update the other one and change traffic to the one that's not been updated and then to the one that has been updated, whereas Kubernetes seems to just take care of all that for you, which I think is amazing.
Yeah, and I think to your point, Eddie, where you would see Kubernetes coming in is kind of personal preference here, obviously, but for kind of production grade workloads, right? The fact that we can do a rolling update, which we're going to show, and we just supply a YAML file and Kubernetes does it for us. We don't have to worry about that. For Eddie to be able to do that with a couple of Docker runs, he'd have to have some kind of bash script or some higher level abstraction that really understands what he means in his scenario for a rolling update. So a lot of this kind of productionizing has been taken care of by Kubernetes itself.
Which I think is awesome. If you had I suppose a side project, let's give a concrete examples. If you had a side project of, I don't know, a Node app with a kind of similar to the small one we've got, but maybe it had your blog on there and had a contact form, would you just Dockerize it, or would you go as far as using Kubernetes for your personal say website and
for me personally
stuff?
If I'm deploying something and it's going to be updated regularly, and I don't want to drop traffic because it's exposed to the public, then I want to be performing rolling upgrades, and I want to be, when that rolling upgrade for some reason fails, I want a way of making sure that my customers or my users always get an experience and always can browse to my website. It doesn't have to be the most up-to-date one, but I don't want to be dropping customers and returning a 404 or a 400. I want to be giving them a good customer experience, and that's what Kubernetes is going to be able to allow us to be able to do.
Nice. I think that's a really good explanation. That is really good. And in terms of pricing, so you've got EKS on AWS. That's the managed service for Kubernetes. Is that correct?
That is correct. Yeah, that's the one from Amazon.
And does that make it cheaper, or does that make it more expensive?
Well, you obviously never move to the cloud to save money, right? You're getting the elasticity, you're getting the kind of resilience. But what it does is it allows you to be able to target and be, concerned and with the things that your business cares about, and that is shipping features to your customers. So that's going to be creating Docker containers up, pushing them to a registry, and then having a way of somehow being able to deploy those to your target environment. And in that case, it's going to be Kubernetes. So if you're new and you want to get this thing out off the ground, then a managed service is great, right? It's going to do a lot of the heavy lifting for you, and you just are responsible for the things that you need to take care of, essentially, and they're going to do a lot of the heavy lifting.
Now that makes sense. And one last question. I am conscious of time. Do you, off the top of your head, know any example pricing of running a small app? I know you've run huge apps or platforms for large banks and so on, but in terms of taking that blog post idea, contact form, etc., and so on, if you were to host that on ECS as just a single container versus if you were to host it in EKS with, say, 2 containers, do you have some rough ideas on what the price comparison would be for like a month or something?
I don't have rough costs, but the thing to obviously bear in mind here is the complexity. So with running EKS, it's you're targeting just a container, so the complexity is greatly reduced. So therefore the cost decreases. But with something like Kubernetes, you need a number of different components to be able to perform this orchestration. So now you're talking about actual machines that are going to need to be there for you to be able to deploy this. So EKS is going to be not EKS, sorry, ECS is going to naturally most likely be cheaper because you've got less infrastructure to worry about, and Amazon are charging on infrastructure costs essentially. But with something like EKS, you're going to get an increase in cost, but you're also going to get an increase in kind of productionization of your applications. So again, it's a trade-off.
Would you recommend someone who's new to this, new to Docker, new to Kubernetes, maybe start off with ECS, get the understanding of that, get their workflow running, and then later on, when they're comfortable with that, stepping up to the next level? Or would you say just do the whole hog, go to EKS if they want that production-like environment?
So for somebody that's learning specifically, I would say everything that we've done right now, we've done locally. So we've run Docker locally, which is the equivalent of, in some regards, running ECS, right? You're targeting running of containers. So we've done that locally, and then we're running a Kubernetes cluster locally as well. There's tooling to be able to do that, and then I would learn that way before necessarily jumping into the cloud. But my personal preference would be learn and get a better understanding of Docker and those kind of tooling locally. And then when you're running in the cloud, I would honestly go straight to Kubernetes. It looks daunting. Like there's a lot of YAML there. We've discussed a lot of stuff. But actually it's quite trivial once you get a couple of moving parts. So deployment is targeting our pods. Service would be for us to be able to route traffic to it. And then we just need to understand essentially that YAML file or those fields and what those fields do to enable us to be able to deploy applications. And then once we have that, it's essentially a cookie cutter way of being able to deploy applications. So we've got your microservice here that we've been working on, but there's no reason why within a couple of copy and pastes we can get that to deploy another workload. Harsh says it's quite intimidating. Yeah, it is quite intimidating. There's no two words about it. But I guess with a productionized system that gives you so many kind of things out of the box, there is that kind of initial learning curve. But then once you've got over that, it's a lot of the same thing over and over again for you to be able to deploy your workloads. So you just really need to get over that that initial hurdle and that initial understanding.
I think. Sorry,
go ahead.
On. I was going to say a lot of things look intimidating when you're new to them. Like if you're new to React or Angular or Vue or Node or whatever it is, then it does look scary until you kind of actually have a play and you go, okay, that starts the puzzle starts fitting together and things start making sense.
Yeah, I would agree with that. I think everything that, for me personally, I don't know if it's the same for everybody, but everything's complicated the first time I look at it. And then really it's how quickly can we distill the fundamentals. And actually with Kubernetes, the fundamentals are relatively straightforward. There's a couple of moving parts there that you really need to understand. And then from a developer's perspective, you're targeting the deployment. So you really need to just take care of those couple of YAML files that we've been talking about and your containers. And all the rest of it's going to be done with Kube, right? We haven't really done a lot there. We've just understood the deployment because naturally I'm lucky enough to be able to understand that simplistically and easily. And then it's just a case of how do I get those resources into Kubernetes and then what happens. But if you want to know the whole thing, then obviously you've got to understand Kubernetes, the orchestrator, and the resources that you're deploying and how those kind of things fit together.
Okay, awesome. Shall we do the last bit?
Let's do it. I'm trying to get you a the last piece of the puzzle that we need. So what I would do whilst I'm doing that is if you get some interaction with the audience there, let's make a change to the background of our Node.js app.
Okay,
let's hard code the image to 1.1.2, and then let's manually upload it to our registry. And whilst you're doing that, I'll get the missing piece of the puzzle that we need.
Sorry, what am I doing? What was the image part? Oh, well, I'll change the version. Sorry, I was thinking of the image background color to an image. Sorry.
Yeah, so let's do that.
Yeah.
So let's change the background color, so and then let's upload a new image. So the new one's just.
So this is what we've got at the moment, and this is yeah. So that's what we've got right at the moment. And then the background color will be changing for the whole body. Okay, so let's change it. What color should we change it to? To make it really dark, like 99. There we go. I think that should be quite dark. See, and then we're going to change the version number as well. So the version number, if I remember correctly, I don't need to change it in here, do I? I'm trying to see how many places I need to change it in. I did see it a couple of places.
No, just in the make file.
Oh, just in the make file. Okay,
when you build it, we've got the version number there.
Oh yeah. Yep. Okay. Cool. So save that. So just a question: when I'm running this on 3000, is that running off the kube cluster? Or is that running off the original Docker container? I think we removed.
That's running off the original Docker container for now.
Got you. Okay. So the next thing we want to do is I want to build it next.
You want to build that, yeah, and then we want to push it to our registry. So you should just be able to do make, build, push, and we should get the new image.
Okay, cool. Make, build, push. Oh yes, it says it there, 112. I saw that somewhere. Wait, it just scrolled up too fast. There we go. 112. And we did change the color. Okay, so it's doing it. And then if I go to Docker Hub, refresh it, we now see 2 tags. Nice, I'm liking that. 112. Awesome.
Okay, so you've done that part, right? So
yeah,
imagine we've got this in CI and we've got some kind of CI/CD system that's automatically on master merges uploading to our registry. But let's actually deploy this thing. So if you go back to the issue, at the bottom there is a section. So yeah, but it's terribly indented because I can't copy and paste. If we so now if we go to the deployment.yaml in our base, and then at the top of that file, underneath label the same kind of there underneath labels. Yeah, let's just sort this in and out. So what we're doing here is we are going to tell Flux that we're going to allow image automation to take place on this deployment. And then I want you to perform image automation, and based on my image, my container name, so that livestream GitOps demo is the name of the container. And I want you to do that using the semantic versioning of 1.1. So what's going to happen is we are going to commit this to GitHub, and then a couple of things are going to happen. So Flux is going to perform the first reconciliation, and it's going to remain on the image that we've specified, so 1.1.1. And then Flux is going to, on its second loop, after a minute, is going to notice this annotation and is going to go and ask the image registry, have you got new images that have this tag? And it's going to go, yes, I've got an image of 1.1.2. And then Flux is going to deploy 1.1.2 for us. And we are going to see the rolling update from 1.1 to 1.2. So if we commit this, Eddie, back up to Git.
Happy with those changes?
That looks pretty good to me, yeah.
Cool, let's do it.
And yeah, semantic versioning is for Harsh's question there, is just the way of us being able to version software. So semantic versioning is kind of, the first one is the major, second one is minor, and then the last one there is patch. And imagine you have an API. So when you're doing a minor change, you're making a relatively substantial change to the code base or the application, but it's not a breaking change. And then if you're going to change your minor or your first value there, so imagine we went from 1.1.1 to 2.1.1, it would be a natural breaking change for the application itself. So it's just a way of being able to do that. There's a URL and a website for semantic versioning and kind of how it works, but off the top of my head, I can't remember what it is.
I can have a quick Google if not, if it comes up.
Sembar.org, I want to say, maybe.
Something like that. Yeah.
Yeah, this is a good thing. We should paste that in the chat, maybe.
Yeah. Okay, so that's pushed up.
Okay, so now do your kubectl command again. So kubectl get pods.
Oh, not that one. kubectl
get pods dash n example dash node dash app.
Example node.
And then do you have watch installed?
I think it's in by default. I'm pretty sure it is.
Just do watch exclamation mark exclamation mark.
What does that do? Oh, one's the previous command.
Previous command.
Yeah, I forgot about that. That's pretty good. Watch not found. Oh, I thought I did have it. Maybe I don't. I can run it again. I can just keep running the command, I suppose. I can be a manual watch.
So we have pushed that change up to Git, and now you can see the rolling update taking place.
Oh yeah, you can see it. That's awesome. If I pause for a second, yeah. Nice.
So what you'll notice here is that we didn't deploy anything to Kubernetes, right? We declared the state of the system that we would like in Git, and Flux has gone and done the polling for us, found a new tag, and is performing the rolling update. So now if we keep this going, we should see a new set of, and a couple of things to note here, actually. You paused at a really good point. So that 0 out of 1 there is our liveness and readiness probes kicking in. So if you look at the time there, it's 30 seconds. And we said that we were going to delay for 30 seconds. So no traffic is going to these pods yet. And then if you do another command, Eddie, you should see these are now 1 of 1. There you go. And now these pods are ready to receive live traffic. So that was our readiness and liveness probes kind of kicking in there.
Nice.
So I'm going to send you another command.
So the background wouldn't have changed on 3000 because that's the old one, right? Yeah. We still have it running on Docker.
So I'm going to send you another command, which is going to be wrong because obviously we're not sharing the same cluster.
A good question by Harsh. Why are there 4 pods and not 3?
I'll get to that in 2 seconds, but that's a good question.
No, well, that's a really good question. I didn't spot that, and I'm thinking about it now. It kind of, makes sense that it's a question, not that it makes sense there's 4. I'm looking forward to the answer.
Whilst we're talking about that, so if we can just go back to the repo a sec in code.
Oh yeah.
And if we go to that deployment that we were targeting, so here. So if you hover over or kind of highlight lines 13 to 16 for me. So we are saying that we want to perform a rolling update strategy, and we're saying max surge 1. So we're saying from 3 to 4 pods. And when you're doing that, I'll allow you to have 1 unavailable. So we're going 4, 3, 4, 3, 4, 3, and then finally 3 with everything. So the reason why you're seeing 4 is because we go up first before we take 1 off.
Nice.
As part of our rolling update.
So you never go below 3 then. So rather than dropping to 2.
Correct. We're still keeping the availability. We don't want to lose the availability there. We want to keep it at 3.
And does it automatically load balance? So after it's been deployed or before it happens, when you've got 3, is it automatically doing the load balancing across all those 3?
That's correct, yeah.
That's awesome. Really nice.
Wow. That's a great question.
That's a really good question and good spot on here. So eventually, will that drop down to 3?
Yep,
it has.
Yep,
yeah.
There we go, 3. And you'll see the time is now. So now what we should be able to do is if we go to the issue again. Don't run this exactly like this, but if we just copy that into your terminal. So if you replace the braces there after slash with one of our running pods.
The ID?
The name. No, the name at the bottom. So where you've got like example node app dash. Come down a bit. Your last command that you run before
that one, for example.
No. The pod name, because we want to target.
Down here. Sorry, yep, you're right. Okay, if I grab
before
that
you
one.
hit enter, let me explain what's going on here.
Yep.
So we are going to port forward, or essentially create a tunnel directly to that pod. And we are going to run that on 3000, and then we know that the pod itself is running, or the container inside the pod is running on 3000 as well. So we are going to establish a direct connection to the container or the pod, and then we're going to be able to do a curl, or you're going to be able to go to your browser, and we should see the new image.
Okay, there is something running on 3000 already. Do we need to stop that?
Let's. Yeah. Or no, actually, let's just change it to 3001 or something.
Okay.
So change the front one. No, yeah, that one. I think it's that.
The first one.
Let's try this.
Okay, let's try this. Okay. Yep. Well, no, wrong way around. Forwarding 3000 to 3001. Yeah, that's wrong, right?
Yeah, that's wrong.
Okay.
So whilst you're fixing that, to Harsh's point, in a real world system that we're running in production, obviously we wouldn't want to do this, but this just saves us having to create something that's publicly accessible. So if you're running, because we're running on Eddie's local cluster, and if Eddie's doing some debugging and he wants to go straight to the application that he's running, he can use port forward to go straight to the thing that's been deployed, and he's going to see exactly what's in there.
So how would I go to the load balancer? So I get one of these 3, as I don't care which one it is, just check that the app's working.
Yep, I'm going to show you that next.
Okay, got you. Sorry, rushing ahead, getting too excited.
So if you go to your browser and go to 3001, there we go.
A lot more information, and the background has changed as well. It's darker.
And what you'll notice there is the host name has also changed. So the host name is the name of the pod.
Yeah.
So if you keep hitting refresh, you'll still get the same pod, because we've established a connection directly to that.
True. Yeah. Keep hitting refresh. It's still there. Okay. Nice.
So yeah, now to your question about how do we do via the load balancer. So let's cancel out of this. Then do kubectl get services. So we want to target a service now. So let's do get services, and then -n, and then example node app. Okay, so we are running on port 80. Okay, so we can do kubectl port forward. So if you copy the command that above the kubectl port forward, and we'll slightly edit it. If you just take the whole line,
okay,
and we'll adjust it.
Oh, I've done that
wrong. Okay, so delete. Yeah, delete. Yep, keep going, stop, and then and then instead of pods, change pods to SVC, so that's short for service. And then our service runs on port 80. So at the back, change the last one to 80, port 80, and then at the front, change it to something like 81. Yep. Oh, it's examples, plural.
With an S. Everyone watching, why didn't you stop that? I'm not there.
Not there. The service name. Yeah.
Got you. So which name is this one? What's that for?
So we are going to establish a connection now, rather than to a specific pod. We're going to create establish a connection to the service, or what we were talking about earlier, which is the load balancer.
Got you.
And our service now is running on port 80. So now what we're going to do is hook into there, and when you hit refresh, you're going to see it cycling through all of the pods.
81 is taken, I think.
Okay, do 3000 and 3300.
3001, right? That should be.
Yeah, that should be possible.
Yeah, because we stopped that one running. So if I refresh this again, we should see. Interesting, that's the same.
I think the port forward may not have been successful because it went to 3000. Port forwarding 3000.
I'll do 2. I'll just do the next number just in case there's a cache or something in the browser, which could be the case. Oh, you're right. It did go to 3000. No, it is going to the old container. It's not going to.
Port forwarding. I think we have it. I think it might be the other way around. So the connection is locally and port forwarded to the. No, that should be right.
3001 brought up that specific one, which we did stop running, so that one shouldn't be running anymore anyway. So if I stop that, and if I just refresh that, okay, it has stopped that service, okay, which is correct, which is what we expect. So interesting. So why would it be going to, it seems like it's ignoring that 80.
Well, it's going via the service to a pod. But what you're doing is, if you go to your browser and go to 3001, are we getting anything now?
We are, but I think it's still the same one. Let me check. We went to the first one on the list, which was this one. ZBJ. You may have aggressive caching on. If you open a new browser, I wonder what we get. Okay, got you. Let me bring up Chrome. Good point. Oh, no, still the same. I can switch ports. If I do 3003. But is that correct to say it's going to 3000 underneath?
Yeah, because 3000 is the container port underneath.
Got you. Oh, I changed it to 3003. Okay. Still there. Interesting. Anyone spot anything that we've missed?
Let me try and figure that out.
Yeah, no worries.
Questions.
I can look through the chat while you're having a look at that, and I can also any recap if anyone has any questions on things we've done so far. Obviously, everyone watching, give the video a thumbs up. I know we've still got a little bit more to do. We'll be going for another maybe 10 minutes. And Steve is doing really well. We've been going for like 2 hours now, and I told him it would be like an hour, and I told other people watching it would be an hour. So apologies. We did have some really good questions, and I know I asked a lot of questions, but it is just so interesting.
I think I have an idea why that's not working, but
okay.
I don't want to go too deep into Kubernetes to kind of confuse everybody.
Okay.
So yeah, I think what's probably makes sense is if we stop there.
Okay.
And yeah, we can see now we've kind of the demo has fulfilled its requirements essentially. So we've taken a Node.js app, we've containerized it and run it locally using Docker. We've uploaded it to the registry. Then the first time we deployed it to the Kubernetes cluster on 1.1.1 using GitOps. And then the next step after that was Eddie added those Flux annotations to tell Flux to look for new images, and it performed an automatic upgrade. And now kind of the kind of mic drop moment is if you go to GitHub and you go back to the main repo, you'll see that Flux has made the last Git commit. So if you actually click that Git commit, if you just click that link, if you click the auto release link, and you'll see here that the Flux patch has said that it's now gone to 1.1.2. So we now have an audit trail in Git of all of the changes that get made to our cluster.
Nice.
So you can see for the deployment node app, we have upgraded the image and we've got it all audited for us.
And if I go back one and I go to commits, the one before that should be my one, which has a bit more in it. So it would have me updating the version, and I also changed the background. But obviously that can get quite big, right?
The key thing to note here is the thing that made the difference was the middle block. So those annotations that we added, that's what told Flux to go and look for new images.
But now if I made a new change, say if I changed the color again, I would
let's do it quickly. Okay. Let's change the color back to what it was.
Okay, good point. Should we get it up and running just to show? Should we port forward back into one of the containers, which was?
Well, I guess all we need to really show to start with is the rolling update taking effect, and then we can port forward to a new pod.
True. Yeah, fair point. Okay, so let me make a change again to the color. So we go here. So I put it to dark. Let's put it to. Anyone know any colors? I don't know. A bit lighter. There we go.
Make sure you go to the make file before you do the build because you need to change the version.
Good point. So change it to a 3.
Yep.
Hit save. Then we can go make, build, push. Is that correct?
Yep.
Do that. We head over to Docker Hub. We'll see a new number appear in a second when this finishes. Hopefully everyone in the chat is still awake. And if I refresh this now, refresh the wrong page. Refresh the YouTube live stream. Right, we've got 1.3.
Cool. So if you keep doing your kubectl commands now, because we haven't got watch,
which
no, the get pods. Next one, up.
That one.
That one. Yeah, keep doing this, and you can see it's happening already.
Wow. That's cool. And so these IDs on the left, they will change, won't they?
They are, yeah. They're unique IDs to the pods that we're running. So you'll see now after 30 seconds, you'll get 1 of 1, and then once we get 1 of 1 on one of our new pods, we can port forward straight to that. Takes a little bit of time. There we go. So let's cancel that. Do a port forward of.
Are they finished? It's done all of them already?
Yeah, it's done. Well, no, it's going to keep going, but essentially, yeah, it's done.
But really, because this is the old number, I think, still from before, isn't it?
Yeah, so it's still going to keep kicking around.
Okay, got you. So if we want to do the forward,
so if you just take one of the port forward, and up one. No, that's the wrong one. We want to go to the pod, and again, that go. One there. Yep. If you just change the
ID, right?
Yeah. So you're going to want the.
I'll just delete the whole thing.
You're going to want the one. Yeah, one of them there. Yep.
I think that's a new one. Got Harsh is still here. Mike's still here as well. Nice. Okay, we're going to go 3001 to 3000. Hit enter.
Perfect.
Go to the browser. 3001. This is what it looked like before. And if we go to 1, you can see it's a bit lighter now. The ID's changed.
And then if you go back to GitHub, you'll see that it's done the commit. So if you go back to
2 minutes ago, let's check. It's gone from 7 to 8. There's another one which is 1.1.3. It's just got that change in it.
Mm-hmm. So now the developers are responsible for shipping images, and Flux is going to handle the deployment, and it will write back to tell you that it's been done.
Got you, but you still, just to check, just to clarify, I didn't push my changes to GitHub because I still need to, because we did the build and the push to Docker Hub. So really that build and push to Docker Hub we should do on CI, so therefore it is triggered by a commit on GitHub. Is that correct?
Correct, yeah. And if you go back to, I think we had an image open on on the repo. I think it's one of your tabs had it open.
When you say an image,
if you just go back to the repo. And go to the docs directory.
Oh, that image. Sorry. I was thinking of a container image. You mean an actual image?
Sorry.
Yeah, makes sense.
So what we've done is we've done both of the sync. So we've done the sync from the Git repo, and then we've also done the pull images. So we've done the top halves of those. And then what we haven't done is we didn't do a kubectl apply. So we've kind of showed the full power of GitOps, taking a Node.js app that wasn't ready for Kubernetes, Dockerizing it, moving it into Kube, and then making constant changes to it without having to make any changes to Kubernetes.
Really awesome. I'm out of questions. I'm in awe. I'm excited. I want to go kind of, have a play, break some things, deploy some things locally and on AWS probably. But this was awesome, really awesome. And I'm conscious of Steve's time as well. We've had him for over 2 hours now. Do follow. Let me bring up. If I switch back to this screen, you'll see Steve's handle swade1987 on Twitter. Go follow him on Twitter and see what exciting things he's up to. Thank you, Harsh. Harsh says a really awesome session.
Already followed you. I look forward to a lot of questions, Harsh. Feel free to reach out, direct message me. I'm more than happy to help you if you're stuck, and that goes for anybody on the chat as well. If you want to get a bit more understanding about how Kubernetes works, just feel free to send me a message and I'll help as best I can.
Awesome. Don't send it privately because then no one else benefits from the Q&A. That's my personal preference. I don't know if Steve agrees.
That's true. But that is also very true.
Tweet him publicly. Therefore, people like me can also see the questions and go, "Oh yeah, I didn't think about that. That question and answer is gonna help me as well." So yeah, it allows Steve to scale a bit more as well and help more people. So definitely keep it public if possible. Steve, thank you so much again. I can see our stats have started climbing on YouTube, but everyone who's recently joined, we're coming to an end. We've had an exciting just over 2 hours and just amazing journey to take a Node app, as we said, to Docker Hub, Kubernetes. Rewatch the live stream. It will take maybe 12 hours or something for YouTube to render it all, and then it will be back on my YouTube channel once they've done it, between 2 and 24 hours. But Steve, thank you so much again. That was epic. My mind blown. I'm gonna have a play, and I'm sure I will might have a few questions for you as well. And what sort of other things, exciting things are you up to? How's any other GitHub side projects you're working on? Any other places you're speaking at?
So yeah, I've got a couple of talks coming up. I'm going to be talking at Atlanta. I'm actually doing a roundtable next week. I'll actually tweet that, and people that are following me on Twitter can join that. But what we've been doing here is we've been deploying workloads. What I'm working on now is I'm working on cluster ops. So I want to deploy clusters with GitOps, so another YAML file, but now we define Kubernetes clusters rather than applications. Got
you. Awesome. Well, I'm gonna digest this and stick to this, and then we'll work up from there. I'm sure we'll get you back in a few months whenever you're ready to a part 2, where we can quickly recap what we've done and then dig deeper into more. So let us know when you're ready. I know you're a busy person, so let us know when you're ready.
Sure, it was an absolute blast. Thanks for having me, Eddie.
Awesome, thank you. I'm going to bring up the holding page now, Steve, but then we'll just catch up for a few minutes afterwards if you've got time to stick around for a few more minutes.
No problem.
All right, thanks everyone for the questions, the chat. Also, don't forget to subscribe if you haven't already. Follow Steve, as I mentioned before, and I'll see you all in a live stream soon. Bye.